Innovation, Uncertainty, Management. Podcast 1, Better Than Digital Logic. This podcast series introduces a unique set of tools I created to help manage the uncertainty associated with early-stage innovation management and other related applications. I start by defining six-state logic, which is an uncertainty-aware idea evaluation system that improves on the performance of more common digital logic-based evaluation systems. When we think of digital logic, a 1 representing the positive state and a 0 representing the negative state comes to mind. Six-state logic enhances digital logic by adding a third uncertain state. The immediate effect of adding the uncertain state is to more clearly define new six-state logic known positive and known negative states in contrast to the uncertain state. Consider using six-state logic to answer the question, tell me if Detroit is a fun town. A digital yes or no answer hides any uncertainty the answerer may or may not feel about Detroit behind a simple yes or no answer. Adding the six-state logic uncertain state enables more meaningful responses like, yes, Detroit is fun and I know why. No, Detroit is not fun and I know why. Or I don't know if Detroit is fun or not. Now let's introduce the 3 remaining six-state logic states located between the 3 extreme states. First is mixed, which combines known positive and known negative states. Next is seems positive, which combines known positive and uncertain states. And last is seems negative, which combines known negative and uncertain states. Imagine the states as a triangle with known positive, known negative, and uncertain labeled corners, and seems positive, seems negative, and mixed labeled lines between the corners. The last element of six-state logic is a text justification for the selection of any of the 6 states. The focus of the justification depends on the selected state. For example, known negative requires a certain and negative explanation, while seems positive requires an explanation that combines known positive and uncertain components. Using six-state logic is as easy as asking a positive or negative format question like, does this idea fit our strategy? And asking participants to select and justify one of the 6 states as an answer. The reasons provided for selections can be very informative, especially in the case where alternative justifications exist for the same state selection. Six-state logic is a unique format of the uncertainty measurement principles well known to disciplines like Bayesian statistics, market research, and control theory. This podcast introduced six-state logic as an improved method to answer yes or no format questions. The next podcast compares six-state logic to the type of detailed multiple choice answers commonly seen in professional surveys. Innovation, Uncertainty, Management. Innovation, Uncertainty, Management. Podcast 2, Better Than Multiple Choice. Podcast number 1 introduced six-state logic as an informative way to answer yes or no questions. This podcast number 2 discusses how six-state logic provides superior performance compared to multiple choice data collection systems. Multiple choice answers are a common extension of the yes or no answer format. Multiple choice answers range from a simple number scale to a list of detailed text descriptions. Consider the question, are you in pain? And the common multiple choice answer scale ranging from 1 to 10 with text explanations provided for the type of pain associated with each answer choice. It is also possible to define multiple choice answers for six-state logic. This would look like 3 sets of multiple choice answers that describe the range of choices between the six-state logic extreme states of known positive, known negative, and uncertain. Most six-state logic applications only use the middle points between the 3 extreme states, called mixed, seems positive, and seems negative. The resulting 6 choices is the origin of the 6 answer choices in six-state logic. The problem with multiple choice answers is the effort required to define meaningful answer choices for different questions. Consider 3 questions. Is this a good idea? Should we go to New Orleans? And is Canada safe? It is difficult to define a single set of multiple choice answers that can describe every answerer's positive, negative, and certain thoughts about these 3 unrelated questions. In contrast to the need for a unique set of multiple choice answers for every different question asked, 6-state logic provides a universally applicable method to answer any positive or negative format question. Simply ask the question, choose one of the 6 states as an answer, and provide a free-form text justification for the choice. It is also possible to simply provide a free-form text answer to any question. Unfortunately, text answers must be interpreted in the correct context to provide similar clarity as 6-state logic answers provide. Due to the need for post-processing to get to the point, and the potential for incomplete or incorrect interpretations, free-form text methods like email are considered too cumbersome a method for investigating the feasibility of new ideas, which is one of the most common innovation management tasks. The key to 6-state logic's universal applicability is the sequence of answer data. 6-state logic describes uncertainty up front in the choice of state, so it does not need to embed qualifying information about uncertainty in multiple choice answers. 6-state logic also puts text justification detail after the choice of state. This sequence focuses the text explanations on only the information required to justify a state selection. The sequence also avoids the need to embed detailed information about alternative justifications inside a set of multiple choice answers. This podcast number 2 describes the universal applicability advantages of 6-state logic as a data collection method compared to multiple choice questions and answers. Now that I've introduced 6-state logic as an effective data collection system, podcast 3 will describe the first 6-state logic application, which is helping users make better decisions. Innovation, uncertainty, management. Innovation, uncertainty, management. Podcast 3, Making Better Decisions. Podcasts number 1 and 2 described how 6-state logic is a superior and universally applicable system for answering positive and negative format questions. This podcast describes how 6-state logic improves decision effectiveness by helping users identify required decisions and avoid unjustified decisions. Let's start by thinking about the root causes of indecision. The first root cause is equal choices. This kind of indecision is represented by the 6-state logic mixed state. The second root cause of indecision is uncertainty. This kind of indecision is represented by the 6-state logic uncertain state. Consider the question, should you invest in this opportunity? Jane has no knowledge and is therefore indecisive due to uncertainty. Jack has many similar successful and unsuccessful investment experiences and is therefore indecisive due to a mixture of known positive and known negative reasons. Even though Jane and Jack are both indecisive, their causes of indecision are very different. Jack's knowledge is complete, but the decision he must make is still difficult due to equal choices. Jane's decision is also hard, but because she is uncertain due to a lack of information. Let's look at the different actions Jack and Jane should take. Jane should avoid making any investment commitment and instead seek knowledge to reduce her uncertainty. In contrast, Jack needs to make a hard choice to invest or not, because no amount of effort spent seeking new information will change Jack's certain knowledge about the mixed nature of this investment decision. The 6-state enabled separation of mixed and uncertain states supports improved decision-making by linking each state to the most appropriate action. Mixed states require difficult decisions to be made promptly to avoid the opportunity cost of delay or the expense of searching for useful new information that does not exist. Uncertain states simply imply a need to search for information that can support a justified decision. The other 4 six-state logic states also play an important role in decision-making. Known positive and known negative states are directly associated with decisive positive and negative actions. The seems positive and seems negative states require judgment to determine the threshold for taking decisive action, searching for additional information, or choosing a combination of both actions. In all cases, when a decision maker knows the state they are in relative to a required decision, it helps them, number 1, avoid undesired decisions, number 2, recognize and make required decisions faster, or, number 3, prepare for the unknown consequences of making decisions with partially uncertain justifications. I suggest you look at the decisions being made around you through the six-state logic perspective introduced in this podcast. You will discover many opportunities to help decision makers justify more consistent and ultimately better decisions. This podcast number 3 introduced the six-state logic framework for improved decision making. Six-state logic is particularly effective as a decision process tool in the type of uncertain environments commonly experienced in innovation management. Next, Podcast 4 will introduce the six-state logic application of creating deeper and denser data structures to illustrate the changing status of any topic.
Innovation, uncertainty, management. Innovation, uncertainty, management.
Podcast 4. Deeper, Denser Status Data. Previous podcasts introduced six-state logic, discussed its improved data collection functionality, and framework for enabling improved decision-making. This podcast number 4 expands the list of six-state logic applications to include deeper and denser data structures that describe the detailed status of any topic. The first step towards deeper and denser six-state logic data is providing an answer to the general question, what is the status now? Simply choose one of the 6 states as the answer to this question and provide an explanation why that state was selected. The next deeper level of status data answers the question, is the status trend improving? In a similar way, select the state that best answers this second question and provide an explanation why that selection is the best answer for the status change question. The next level of deeper and denser status data helps users understand if the status can be actively improved by the status evaluating person or team. Once again, use six-state logic to answer the question, can we act to improve the status? Consider the application of the status of a major customer revenue forecast. A forecast number is provided for accounting purposes, but a six-state logic status indicator can show how well that forecast number compares to expectations. Now use six-state logic 2 more times to describe the trend status and the ability to impact a change in status. In a dashboard display, it is convenient to show the status indicators as 3 concentric shapes. Consider 3 rectangles or circles that display current status as the center shape, the change in status as the next larger shape behind the first shape, and the ability to make improvements as the third shape behind the first 2 shapes. For color choices, I like green for known positive, red for known negative, and gray for mixed, with white for uncertain, light green for seems positive, and light red for seems negative. In the previous example, a manager viewing the revenue forecast status indicator could see the actual forecast number inside of a rectangle colored light red indicating a seems negative status compared to expectations. That light red rectangle could be surrounded by 2 concentric light green rectangles indicating seems positive prospects for change and ability to influence change. The manager could point their mouse at any of the rectangles to see the detailed justification for that status indicator. Podcast number 4 explained how 3 layers of related 6-state logic information can be integrated into a deep and dense status indicator dashboard element. The primary application is to help users quickly track the complete and actionable status of a wide range of potentially rapidly changing topics so they can make better informed decisions. Next, podcast number 5 explores how horizontally related 6-state logic data structures can support the application example of new product idea feasibility evaluation.
Innovation, uncertainty, management. Innovation, uncertainty, management.
Podcast 5, Multiple Evaluation Perspectives. Previous podcasts discussed how six-state logic supports easy, accurate, and deeper-level data collection. This podcast number 5 describes how six-state logic enables more effective evaluations of the investment worthiness of new product ideas. The multiple perspective evaluation method introduced here is generally applicable to any complex and partially uncertain investment decision. Multiple perspective evaluations of new product feasibility help illustrate and utilize the differences in feasibility perspectives between the functional areas of an organization. For example, engineering may like a new product idea that sales does not. Strategic fit is the most important feasibility evaluation perspective because it provides a summation of the relative importance of all evaluation perspectives and documents the ultimate justification for any new product investment. The second most important evaluation perspective is financial performance. Financial performance summarizes the idea's comparative financial value and the quality of available financial information. For example, a 6-month investment payback may be great for one organization, but intolerably bad for another. In contrast to the all-encompassing strategic fit evaluation perspective, the evaluation of financial performance is constrained to only the financial facts. For example, if engineering is uncertain about the cost of an idea, then financial performance must also be uncertain because the information to create a business case does not exist. The contrast between the broad summary evaluation perspective of strategic fit and the narrow summary evaluation perspective of financial performance helps organizations recognize, categorize, and manage different types of investments. Six-state logic evaluations of both perspectives generate 36 different categories of potential investments. This level of analysis helps organizations efficiently recognize and avoid many common investment problems, like always investing strategically without consideration of financial risk, or the opposite problem of always investing based on financial data without broader consideration of strategy. In addition to summary evaluation perspectives, six-state logic helps improve the quality of independent descriptive evaluation perspectives like technology control, operational readiness, and commercial acceptance. These 3 common evaluation perspectives are typically unrelated to each other and can therefore be split into the subcategories of hardware, software, knowledge, and human resource feasibility if more descriptive information is required to support strategic and financial evaluations of a new product idea. A primary goal of multiple perspective evaluations is improved decision-making. The topics of evaluation may change to fit an organization's requirements, but any evaluation perspective will either broadly or narrowly summarize other perspectives or be descriptive in nature. It is the combination of independent perspectives and six-state logic evaluation rigor that makes the multiple perspective evaluation process a useful tool for new product investment decision-making. This podcast described multiple perspective evaluations as they generally apply to new product ideas. Podcast 6 explains how six-state logic also helps evaluation teams quickly and accurately reach consensus decisions.
Innovation, uncertainty, management. Innovation, uncertainty, management.
Podcast 6. Better Consensus Teamwork. This podcast number 6 describes how six-state logic enables teams to efficiently and effectively reach consensus decisions about any evaluation topic. Teamwork improves the quality of decisions, but comes at the cost of reaching consensus. Balancing the benefits and cost of teamwork is especially challenging when the topic of discussion is uncertain, as is many times the case for innovation management. The six-state logic feature of more exact state descriptions helps teams more quickly and accurately reach consensus decisions. As described in earlier podcast, yes or no communications are inexact, and detailed multiple choice or free-form text communications are time-consuming. Six-state logic therefore helps teams focus on the barriers to reaching consensus rather than wasting time defining what consensus means. Six-state logic structure makes consensus in a general form like seems negative meaningful enough to support next step decision planning without requiring team members to agree about all supporting details. For example, one team member may believe a technology seems negative because it is probably uncontrollable, while another team member may believe the technology is probably too expensive. Six-state logic enables these two team members to agree on a seems negative evaluation result without forcing them to unproductively agree on the exact reasons why. The six-state logic consensus building process, or algorithm, starts by requesting team members to compare their individual six-state logic evaluation results. Certain team members contrast opposing results, while uncertain team members collect information from public exchanges that can help justify more certain evaluation results. Consensus is reached when all team members choose the same six-state logic evaluation result. Such perfect consensus is not always possible without encouragement in the form of voting or importance weighting. Voting is the process of forcing team members to select one or more evaluation results to follow. The voting process represents a tournament that pits evaluation results against each other to select a consensus winner. Importance weighting assigns a higher value to some team member evaluations and results in a distribution of six-state logic responses. Some team members, like a CEO, may have more weight in a final decision, while other team member inputs, like a consultant, may have zero weight but are still used for reference purposes. Typically, thresholds are defined for the concentration of results in a distribution that will be recognized as a consensus. Voting and weighting techniques for reaching consensus can be used together to further improve teamwork, speed, and accuracy. The six-state logic consensus teamwork process introduced in this podcast relies on the fundamental six-state logic communication advantages introduced in earlier podcasts, as well as an effective sequencing of how evaluation results are compared. The result is a consensus process that works well in both live meetings and through asynchronous communication methods like email. Podcast 7 describes how multiple six-state logic tools and well-accepted innovation-supporting methods can be combined to form an overall effective and efficient process for ideation and new idea evaluation.
Innovation, uncertainty, management. Innovation, uncertainty, management.
Podcast 7, Better Ideation Process. This podcast describes the active and passive roles six-state logic plays in a full ideation support process. The first step for ideation stimulus is goal setting, which helps focus and stretch the imagination of ideation participants. Goals can be specific, aspirational, or expansive. Doubling revenue, reducing cost, or creating winning new products are examples of goals that fall into these three respective categories. The next recommended step is understanding the obstacles to achieving ideation goals, which further helps participants focus their imaginations on useful ideation objectives. The next step is listing as many ideas as possible that can overcome ideation obstacles and achieve ideation goals. Ideation almost always benefits from continuous effort, good organization, and a no idea is too silly to consider attitude towards innovative thoughts. Ideation meetings, if they occur at all, are better spent setting up ideation efforts and evaluating ideation results than attempting to define a particular time frame for new ideas to occur. After ideation, six-state logic is used to evaluate the feasibility of new ideas. Evaluating all types of ideas, from the known positive to the known negative, and the hopelessly uncertain, helps ideation teams further calibrate their efforts relative to concrete objectives. Where applicable, consensus teamwork and multiple perspective evaluations are used to improve new idea evaluation efficiency and effectiveness. Evaluated ideas are either acted upon or maintained in an inactive idea database. Deep and dense database entries make ideal containers for updating the status of both invested projects and inactive ideas. Refreshing evaluations when new information is available or using the idea database for ideation stimulus are common best practices. Six-state logic-based Automation enables every ideation participant to know their next best action given the latest inputs from all other participants. Algorithms determine the lowest effort path towards evaluation consensus and also help mine individual text justifications for valuable supporting data and new idea stimulus. This podcast introduced a six-state logic enhanced ideation process. Six-state logic helps ideation participants broaden the scope of imagination by reducing the effort required to work with many uncertain ideas. Six-state logic also speeds up evaluation teamwork and improves the accuracy of consensus decision-making. The next podcast introduces how six-state logic improves first-time encounter communications between people and machines in a network.
Innovation, uncertainty, management. Innovation, uncertainty, management.
Podcast 8, Better Network Communications. This podcast describes how six-state logic improves first-time and persistent encounters between people and machines in a network. Communication is defined as the exchange of information that leads to state changes and ultimately to human-authorized actions. I assume network participants can broadcast six-state logic status signals about any number of topics to any other network participant. The default state of any participant in a six-state logic network is uncertain. The uncertain state signals openness to new information and ability to refuse being forced into undesired positive or negative actions. In contrast, known positive and known negative states are associated with immediate desire for well-defined positive or negative actions. Most six-state logic network communications occur in the uncertain, seems positive, and seems negative, and mixed states. The mixed state signals indecision and no desire for additional information. Seems positive and seems negative states signal a desire for more information and inclination towards either positive or negative actions. Consider this hypothetical interaction between a sales machine and a purchasing machine. Sales, known positive, do you want to buy? Purchasing, uncertain, tell me more. Sales, known positive, gives information. Purchasing, seems positive, need human authorization. Sales, seems positive, waiting, will update changes. In this example, sales makes its pitch, which purchasing matches against known requirements. The machines exchange information like price, inventory, and creditworthiness to advance the transaction as much as possible before external events, like sales running out of inventory or human authorization to proceed, determine if the opportunity becomes a concluded transaction or not. Six-state logic-enabled machine interactions emulate human desires and transaction style with the advantage of machine speed and processing capacity. In this case, the sales machine is authorized to find potential customers and to sell its entire inventory as soon as possible. The purchase machine is authorized to find the best possible deal and bring it back for human review and possible authorization. A big advantage of six-state logic networks is the machine's ability to identify and maintain large numbers of potential interactions with many participants. This six-state logic feature helps augment human communication resources in ways that reflect human feelings of uncertainty, optimism, pessimism, resignation, and desire for immediate action. This podcast introduced six-state logic networks based on discrete changes of state. Podcast 9 introduces the complementary concept of six-state logic search, which enables network participants to prioritize network communications and communications with humans that use the network.
Innovation, uncertainty, management. Innovation, uncertainty, management.
Podcast 9, Better Database Search. This podcast introduces six-state logic search, which provides the foundation for numerous six-state logic applications. All the six-state logic benefits compared to digital logic described in previous podcasts are also evident in this comparison between digital and six-state logic search. Consider a simple digital logic search of a database for an item that matches selected characteristics like size, color, and cost. The search result will show all database items that match the search criteria. Common problems with this simple digital search process include: number 1, too many or too few indistinguishable search results. Number 2, an all or nothing match result makes it difficult to capture partial match information. And number 3, the need for design effort to assure digital search criteria match database contents. Instead of listing all or nothing database matches, six-state logic uses a 0% to 100% tuning bar to collect information about the positive or negative intensity of desire for database item characteristics. It is possible to merge the six-state logic uncertain and mixed states at the midpoint of the tune bar because there is no difference in the desire signal provided by these two states. Six-state logic tuning bar inputs for search criteria are then multiplied by a similar tuning bar-like description of how well database items match the criteria. The result is summed to create a relative search satisfaction number used to rank order search results. Key advantages of this six-state logic search process compared to digital search include: Number 1, more points of database item differentiation, resulting in fewer same-ranked results. Number 2, ability to rank the search result satisfaction of all database items from 100% to 0%. Number 3, ability to make changes in search criteria without the need for database content knowledge. Maximum search item differentiation is achieved by using Number 1, tuning bar inputs for every search criteria. Number 2, additional tuning bars to show the importance of groupings of search criteria. Number 3, more continuous search item data like showing where an item falls in the spectrum between very large and very small, instead of just categorizing the item as small, medium, or large. The applications for the six-state logic search techniques introduced in this podcast include: Number 1, database scanning by adjusting tuning bars. Number 2, matching networks where tuning bar desire inputs and database search data are the same. And Number 3, real-time priority ranking search results that support specific applications like knowing which task a customer service agent should do next. Podcast 10 will next explain how six-state logic search improves and enables better communication network performance.
Innovation, uncertainty, management.